Hello and welcome back to Series and Sequences. First, as always, I want to thank all the nice people that support this channel by liking and subscribing. It means a lot and really helps for me to make more videos for you to enjoy. In today's part 7 and the final part of this short series, I want to go over compound interest. If you are interested in finance or money in general, you might have heard a thing or two about this. Now, the real question here is this. Would you want 1,000 euros right now? Or would you want 1,000 euros growing at 10% annually in 10 years? For most, you probably chose the second option because your money will grow without you doing anything. But now the question is by how much? So let's see. Let's say you put or invested 1,000 euros at the beginning of the year. So that means after 1 year, you get 10% back. So now 1,000 times 10% is equal to 100. So if we originally had 1,000 euros, now after 1 year, we're gonna have 1,100. Now we have 10% of 1,100 after the second year. That would be 110 added to your account at the end of year 2. So now we're going to have 1,210. After year 3, 10% of 1,210 is going to be added to your account. That means 121 will be added. So now that means our account is now going to have 1,331. We could keep calculating it like this, however, there definitely should be an easier way to do this. So now let's just say that the value after 10 years can be denoted with the letters F and V with an index 10. In this case, FV is going to mean future value. So now, if we were to calculate the future value after 1 year, what we did is we took our 1,000, or we can also write it in a general form as PV, which denotes present value. And then we multiplied it by 1 plus our interest rate R, or in our case, it was 0.1 because 10%. However, now after the second year, the future value with an index 2 can be calculated with the present value multiplied by 1 plus our interest rate, this time squared. So the number of years that have passed is going to correspond to this power right here. So in a more general sense, after n years, this here would be raised to the power of n. And here we would have a basic formula for calculating compound interest. So now let's use this formula to calculate our 1,000 euros growing at 10% annually and how much is going to be in 10 years. So now the future value after 10 years is going to be equal to 1,000 multiplied by 1 plus our interest rate 10% or 0.1 raised to the power of 10. And the answer here we're going to get is 2,593.74. Now we grew our investment by over 150% without actually doing anything except for being patient. And that is great. However, in the real world, there aren't many places where you can put your money and get guaranteed 10% every single year. At best, putting it into a bank or buying government bonds have the least risk and can get you approximately 4 to 5% or sometimes maybe even less. However, now let's say we come across another opportunity where we can get the 10% compounded monthly on our investment of 1,000 euros. Of course, this does not mean that you get 10% of our investment every single month, but rather that 10% is spread out across the 12 months or an entire year. In that case, our formula is going to need another adjustment. Mainly, the interest rate is going to be divided by the compounding periods, and then the number of years is also going to be multiplied by the compounding period per year. So that means if it's compounded annually, this k would just be 1, like in our original example. If it's compounded semi-annually, your k is going to be equal to 2. If it is compounded quarterly, that means every 3 months, your k is going to be equal to 4. And lastly, if it's compounded monthly, that means k is going to be equal to 12. Now I can also tell you that sometimes this formula can be written in an alternative way. Now there isn't much difference except this division by 100 here, because in this formula, if you have an interest rate of 10%, you just write 10 instead of r and not 0.1, because the formula would divide the 100 for you. Whichever version of the compound interest formula you use is purely up to personal preference. Another thing that I do want to point out is that this formula right here isn't only used to calculate money. If we simply change the variables to just x and y, so now writing y is equal to x times 1 plus r divided by 100. In this case, the r would be the growth or decay rate, and then raise it to the power of n. This formula can be used to calculate anything like population growth or decrease over time, or perhaps bacteria growth, and just about anything else. So also sometimes you might see this formula being used with the plus minus sign. Just remember, if you use the plus sign, that just means you're calculating the growth of something. If you're using the minus sign, that means you're calculating the decay or decrease of certain thing. So that's it for now. I really hoped that you enjoyed this short series about series and sequences, and I really do hope to see you in future videos. Wish you luck and have a nice day. Bye!